Can robots save the world? We know they can at least help improve the reliability of our power grid. Our guest this episode will share how. You're listening to Energy Solutions, a podcast from the Electric Power Supply Association, where we showcase the voices and stories behind America's changing electric grid. I'm your host, Todd Snitchler, EPSA's president and CEO. Innovation created today's energy industry, beginning with Benjamin Franklin's kite experiment more than 300 years ago. They don't call it a light bulb moment or a spark of genius for nothing. But we can't keep relying on centuries and decades old technology to deliver solutions for today and tomorrow, especially with today's reliability challenges. The good news is there are a lot of innovators with new ideas that are improving the grid as we speak. Jake Loosararian is one of those exciting innovators. He's the founder and CEO of Gecko Robotics, which protects critical infrastructure by collecting data using Gecko-Like robots that can scale power plant walls and crawl inside dangerous environments like nuclear reactors and giant boilers. You can catch Jake in person in Washington, D.C. at EPSA's second annual Competitive Power Summit this March. Stay tuned and check out our website for more information. Meanwhile, here's our conversation where he shares how he's developed this technology, how it is helping create a more reliable and affordable power system, and what is needed to spark more innovation and energy solutions. Thanks, Jake. I appreciate you taking time to visit with us today. I've got a bunch of questions that I want to ask you because I'm really interested in the technology and the work that you're doing. But I think in full disclosure, I always want to make sure that folks know maybe how our guests have come to us. And Jake and I are both Grove City College alumni. And I think it's safe to say we're both incredibly proud of our alma mater. And I got to know Jake through a common friend who was invested with Gecko and in Jake, frankly, because of the real value proposition that his organization can bring to a number of industry segments, including the power generation sector. So with that disclaimer and kind of how we were introduced behind us, Jake, kind of talk to us a little bit about what Gecko Robotics is. What is it your company's doing, and how does it fit in the greater power sector and the other parts of the economy that you're working in?
Well, thanks for having me on, Todd, and thanks for all the help with connecting and your perspectives on the energy markets that you provided me in the past. But Gecko Robotics is a company that's focused on protecting today's most critical infrastructure and helping give form to tomorrow. And we do that by creating wall climbing robots and also other sensors that are able to help decode what the physical world, what the health and integrity of the physical world looks like. So we build these robots that go out into power plants, into refineries, on the side of ships and boats, as well as hydroelectric dams and other assets. But what we're trying to do is we're trying to gather structural integrity data that can help predict when things will fail. And that creates a data layer. And that data warehouse is something that we've been accumulating since I created Gecko in 2013. And we've developed incredible software on top of that data layer to help some of the biggest companies in the world predict when their critical infrastructure will fail. So it really speaks to a reliability crisis that we're trying to solve with first principles.
You talked about a climbing robot. Can you kind of describe, for those that haven't seen it, what does this physically actually do? Because it sounds almost futuristic.
Yeah, absolutely. So I'm an electrical engineer and made this wall climbing, the first wall climbing robot in college because I stepped into the world of a power plant. But what the robot actually looks like is it kind of looks like a Tesla Roadster, maybe not as flashy, but it's the size of a briefcase. Mm-hmm. And so you take this robot into maybe it's a pipe on a pipeline or on a tank, on a boiler inside of a power plant. And you release it into the wild. And the robot is using ultrasonic sensors, using visual sensors, and a slew of other kinds of sensors to try and understand the health and structural integrity of whatever it's climbing on. So this physical world, this question I was plagued with in college was, why do I trust the infrastructure around me? That's kind of like, we all go to the doctor and the doctor tells us, oh, you have all these things wrong. You should do these things to help fix the problems. We don't really have a great doctor in the world of physical things on the energy infrastructure side when we talk about physical things. So The robot is the doctor. The software is helping to inform our customers. Again, the top power, oil and gas, manufacturing, DoD customers in the world. We're trying to help inform them on exactly when things will fail, why they're going to fail, and use large data sets to help create a predictive future, a prediction on reliability and availability of the critical infrastructure that we rely on. So whether it's a bridge or a power plant, we want to know exactly what's going on.
Right. So this is like wall thicknesses on those tanks, or it's the strength of the boiler. So rather than find ourselves in a situation where you have a complete failure, what your technology allows the asset owner to do is see into their own asset and identify where there's a likely failure that's at some point in the future they might not otherwise be aware of.
That's captured really well, Todd. And I think maybe it's important to also underscore, why what the problem actually was, why we decided, why I decided to build the first wall climbing robot to do this. And I can kind of do that through the story of the creation and the idea of coming up with a first wall climbing robot. And so I was in college at incredible Grove City College that me and you both attended, doing electrical engineering. And so anyway, I was an electrical engineer and didn't really understand how power worked. Was really obsessed with energy and what energy of the future was going to look like. This curiosity took me to a local power plant in Oil City, Pennsylvania. And this is a cool area for those who love history, where the Industrial Revolution kind of kicked off. And so I got to walk into this power plant, which was a new power plant built in the 1980s. I love saying that to people because people don't understand and realize that the world is run by Cold War era infrastructure on the energy side. And so walked into this boiler, which is the piece of equipment that turns water into steam when you heat a really large box of tubes up. So think a football stadium 200 feet up in the air. With the walls being tubes carrying water, and the power plant engineering manager there said, "Yeah, we experience about 40% of the year shutdowns and lost generation at our facility. This is a very small independent power producer, and which is kind of normal for power plants like this. And they typically are shut down most of the time. They're shutting down because these boiler tubes continue to fail on us and explode." From the pressure inside of the tube and the erosion and corrosion and cracking of the steel infrastructure. And I said, wow, that sounds like a crazy problem. There's so much potential areas for things to break. How do you stop it from failing? And so he described this process that have existed for a long time, where you send a human on scaffolding or hanging off of a rope with a handheld ultrasonic transducer or a flashlight, and you're trying to look for a needle in a haystack. Where's the low points where things are going to fail? And actually, a year ago, someone had fallen and died doing that, which is unfortunately not uncommon for death or injury for these types of hazardous jobs. And but fundamentally, it also wasn't working that well. It was very slow. Wasn't able to stop the problem from happening. And so this compelled me. It made me super curious to try and solve the problem of what I saw was a data capturing problem. And so with a robot I built in college, a wall climbing robot that could scale the walls really, really quickly, because every hour they're down, they're losing, and this plant was losing hundreds of thousands of dollars. Refineries are losing $40 million a day that they're down. And and the robot was able to do the inspection at least 10 times faster than a human could even set up the infrastructure to go see things, but also capture thousands of times more data, and now we're at millions of times more data than ever before, to be that much many times better at predicting when things will fail. And obviously we did it safely because the robot was in the dangerous height instead of the human. And so anyway, that year we saved about 3/4 outages with the robot that I made in college, and that opened my eye up to this problem of predicting when things will fail. And fundamentally trusting why do I trust the infrastructure around me? And that's been a question that's plagued me. And the mission of the company is to protect today's most critical infrastructure and help give form to tomorrow. which I'm excited to talk about the giving form to tomorrow part. But yeah, that question just drove me crazy. And so anyway, built
Sure.
Gecko in 2013.
So you just gave two numbers that I think are amazing when you think about an outage rate of 40% because they had continued problems that were plaguing the system, and then your improvement rate. Can you tell me that number again?
Yeah, it's so the improvement rate. So just with the robot I built in college, which was super ugly compared to the
Sure.
robots today, did save them three forced outages, which was
Three forced
about
outages, which is real money to a power generator because, as you noted, that means they can't run and they can't generate any revenue. And so it's
that's right.
vitally important that that plant be able to operate.
Well, especially for this independent power producer, which
Hmm.
obviously the most the worst problems occur when you're shutting down and starting up because of all the temperature change,
Yep.
but also when you're loading. So when needed the most, independent power producers and plants like this, reliability is extremely important, and we base so much on with as it relates to rates, but also that power plant makes all their money potentially in that month. So if they're if it's in the dead of winter and the power plant has to shut down because of tube failures or other failures in the system, well, shoot, they're going to power through and destroy the unit even more for the profits, which really low thermal efficiency, which means your emissions levels are high, efficiency and burning is high, but also you're if you shut down, you're also screwing with some of the numbers and the predictions by utilities and larger organizations. So it
Yeah, it's a
ends
grid
up
reliability problem at that point.
it's a grid reliability problem. That's right. And this is an example that started in power, Todd, but the deeper you look into other industries that use physical things and that whether you're making something or you're shipping something from one country to another, or you're or you have a dam, an aircraft, all
Hmm.
these things come back to reliability of structures. In order to solve some of the things we talk about at the meta level, at the high level, you first have to understand like why things break, why
Hmm.
they fail. Society is run off of technology and infrastructure that was built in the 50s, 60s, 70s, and 80s. And that is those structures are reaching useful life or they've reached it. And so the question and the problem, and this is what we talked recently at the World Economic Forum in New York this week, and recently in Pittsburgh at the Global Clean Energy Action Forum,
Hmm.
was about a just transition. How do you ensure that as you transition to less carbon emissions towards net zero, how do you do so in a way that doesn't leave people behind, that
Hmm.
doesn't create large job loss, that doesn't create large inequality of access to energy, high prices of energy.
Yep.
We're seeing this obviously in Europe, and we'll see it this winter as well in the US. But the reliability crisis that Christy talked about on your last podcast is a real big topic that we talk about every day at Gecko.
Hmm.
But we're trying to solve it by measuring things as small as possible to address problems that are very big. One of the things I'll also note is the 2013 example I gave you.
Hmm.
That was it was three forced outages in the first year after development. Now we're at the point where one of the largest utilities in the U.S. that is an amazing customer of ours. They're using the Gecko program, software, predictive software, data analytics, and obviously the robots that are creating the data. They were able to go from 14 forced outages at their largest power plant, 14 outages a year down to zero within 2 years. They do not shut down this facility unless they want to.
Yeah.
And when they do shut down, they know exactly where to go fix things because they have incredible high fidelity of data that our robots and sensors are able to provide them.
Hmm.
And so when they do shut down, everything's ready to go. It's a very efficient process, and this is also true on the pre-turnaround side on the oil and gas sector. If you know exactly where to go fix things and where the problems are, wow, it's incredible the savings and the ability to live in a world where you don't have to react to things breaking. But anyway, what we see time and time again is companies that are telling that are telling these large manufacturers or these large producers that your equipment will be good for the next 50 years, or maybe your equipment is so bad it's going to take you so much time and money to fix this thing.
Right.
It's just not worth like fixing. You should totally buy a new tank or something like that.
Mm-hmm.
And so recently at the largest pulp and paper manufacturer in the U.S., we came in a day. We used robots to collect this incredible high fidelity digital twin and map of the structural integrity of the asset. And we said, instead of this tank being replaced and you spending $10 million, here's a way to fix it for $1 million, and we can extend the life of that asset by 15 years. And here's the steps.
I'm thinking they were pretty pleased with that.
Yeah, not bad for a week's work.
Yeah.
And so they they said we need this done at every asset we have, and so we're doing that. But it's and at an oil and gas facility, like the largest refinery in the U.S., there's a similar problem where the traditional method of doing the data gathering inspection, the company previously said that this asset was good for 100 years. We came in and found micro cracks because of hydrogen-based damage that was occurring at this asset that was potentially months away from large ruptures. And this is the kind of asset that would take down a refinery, about 60% of the production of the refinery, for multiple weeks.
On any number of levels, that's a bad outcome, particularly given high gas prices and all the other things. So these are real life examples of what the benefit that's being provided by that technology is delivering to the asset owner, of course, but ultimately to consumers.
Right. Okay. So what's interesting about robotics, it looks really good typically on a marketing doc for a big company or some initiative that someone's trying to push. You can display these things as, look how great this company is at advancing new technology and pouring into new technology. Very few times do those technologies actually change a core business metric for a customer. Yeah. And fundamentally, what's interesting about these industries is they, whether it's energy or oil and gas, they create the most data of any other industry. However, the utilization of the data is very, very bad. Actually, one of the biggest companies in this space that collect the most energy or the most data, operational data in particular. Their CTO and I were talking the other day, and mentioned how they collect hundreds of thousands of terabytes of data every month per facility, but only know how to use a little bit less than 1% of it.
Wow.
And I think what's incredible, you have the most data of any other industry within these industries, but it's very difficult to actually understand how to use the information and data in a way that transforms industries. The energy and infrastructure space have not been transformed by data and digitization, even though marketing might tell you otherwise. What we're doing, what's interesting about robotics is, in particular, our robotics is we focus a lot on why is the data worth a damn. Pardon my language, but why is the data worth anything?
Yeah.
And so, and not assuming that it's worth something. And if the information we're collecting cannot track towards a better outcome for the customer, and by that outcome I mean utilization increase, extended life
performance,
improved performance, extended life of assets. How efficient can you actually make your facility? Should your rates be lower on the insurance side than they currently are? It's these types of outcomes that are really important. Obviously, there's a couple that are more important than others.
Sure.
Safety and reducing hazardous work hours. These kinds of things. Whether maybe it's even on the ESG score side. It's you have to be able to map these new data sets or the existing data sets. How can they actually improve the performance of the facility? Does the CEO or CFO care at all about the data you're collecting, these new data sets you're collecting?
Sure. Let me pull you back to the power sector and ask a question that, what's the reception been like across the power sector, and how it's worked for you to engage in that space? Are you getting the reception that I would think you should, or are you finding resistance?
Resistance in the power space in particular, it's been incredible. It's been an incredible industry to start in. The reason I say that is in 2013, launched Gecko into the power sector. I basically lived at a power plant building robots and putting those robots in the environment time and time again, seeing where it failed. And a power plant let me do that. So they were like trying, especially this IPP.
Those are our people. We're glad to hear you say that.
People, right? It's because the independent power producers, it's real capitalism, right? You're trying to make as much return as you possibly can, and it's very clear.
If we're not running, we're not getting paid. So it's vitally important that equipment works.
Exactly, and you want to make sure as well. Like what I found fascinating is these private equity firms that own a lot of the independent power producers. A lot of times when they buy things, they don't really know what they're buying. And we have some pretty interesting insight into exactly what's going on at the metallurgic level of every inch of the asset, whatever the asset is. So anyway, independent power producers were actually the bread and butter of Gecko early days. We didn't really work with utilities, and this was 2013 to 2016. I bootstrapped the company and was completely broke, and then staved off. And there was an acquisition offer I turned down. Decided to take investment from a venture capitalist in the Valley called Y Combinator, and then moved to the Valley. 4 months later, moved back to Pittsburgh after raising a seed round. Anyway, we've raised about $130 million since then. I could talk about that too, but in particular, the question you asked, the independent power producers were the most willing to try new things, which was incredible for the beginning stages of Gecko. And we created some pretty amazing outsized returns for them as well. The amount they paid versus the amount they saved was incredible. But that allowed for us to truly understand what the value proposition was and what we're actually doing to affect them. But every single independent power producer, just like every single utility power plant that we work with, and this extends in some ways to other industries, but specifically power, the questions were completely around. We're very skeptical of a new tool that was being used, and we had to go out and interact with those amazing people that knew so much about such a critical set of assets, and also fundamentally an industry that we all use every day, but we never heard about these people. And they got to see the robot live compared next to a human using a handheld tool. And then so there was prove to me that you're worth it was the attitude. So very gritty, which actually aligns super well with the core value of Gecko.
Again, these are your people.
Yeah, that's right. And yeah, exactly right. And so these, the engineering manager here, power plant manager there, maintenance manager there, all these different facilities across the US. It wasn't like one and done. Like here's what we did over at this site. Aren't we great? But it was going to conferences, industry conferences, talking to people, presenting our data, and just having lunch and learns and demoing this stuff in the early days. And now it's obviously a lot more scaled out. We have great relationships. We've been going back to customer sites for such a long time now, and continuing to add more and more things that we do for the customers. And now that we're launching these new data and predictive software tools, it's a whole another dimension deeper that we're looking to go with customers. But what's interesting about power, I'll end with this, is that the barriers to entry were not as difficult as some other industries. So starting in power,
interesting,
allowed for us, opposed to like starting in nuclear, where like contracts would have been bigger, would have been way bigger. Oil and gas would have been way bigger. But power allowed for less barriers to entry to try new things, and that was a lesson that I hope other technology companies that are obsessed about building incredible solutions in this space heed, because independent power producers and power space in general was an incredible place to start.
So now that you've got the data and the experience and you're able to deliver some of these results, is there's, I won't bore our listeners, but there's really four segments to the power world. There's the utility space, there's public power, there's the rural co-ops, and then there's independent power producers or competitive generators who we represent. And they all have different objectives and different business models, but we all want to do a couple of things regardless of the model. And that's to operate safely and to operate reliably. Do you find that you are getting access points to all segments of the industry? I mean, I know you talked about how we were a good test market in the independent power sector, but I hope that the answer to my question is, yeah, it's easy. I call and we get in there and do it, but I suspect it may be harder than that.
It is straightforward. And by straightforward, maybe I should describe why people say no
Sure.
to Gecko. People say no to Gecko because it's the creed of the powers that be are keep O&M costs as low as possible.
Yep.
And we're more expensive than a human doing this. However, that doesn't factor in the cost of like accessing the thing that you want to actually get data on. If you look at that plus time it takes to get the data, crazy cheap. But hey, I have this budget for this thing.
Sure.
If I don't want to increase it, so say no. The other thing that people say no is, hey, we've done it this way for a very long time. I know this contractor, and we're just going to keep using it. The other thing they say is, hey, we'd much rather just spend a couple $1 million just metal spraying or overlaying, or some sort of like wear material. I can get into why that's a bad strategy, but I think that's and to describe the three reasons people say no in the power sector. Those are the three reasons. However, the growth rates and the amount of customers that we work with the largest customers in all four of those segments that you've listed, and it's really just it's just how fast can we keep up with the demand is the problem right now. So we've just built 50 new robots, or deployed 50 new robots out into the wild, and that's and that allows us, because we continue to use those robots from site to site. And then also some customers just have us there every single day collecting data, and that's typically where you see the best results.
Yeah, I guess I should be careful because I'm sure my members would like the competitive advantage of making sure their equipment can run safer, faster, longer than anybody else's. So maybe I'll stop asking you that line of questions and we'll talk about something else.
Well, I think what's interesting, especially when you look at when you zoom out and you look at we're the grid has never been stressed more. The supply and demand curves and the CAISO, MISO, ERCOT grids look a little bit scary this upcoming winter. Looks scary in the summer as well. Europe, don't even get started on the concerns we have there. These conferences that I've been speaking at and been at with the World Economic Forum and other forums.
Congratulations, you've added quite a few pretty high-profile stops to your resume over the last 6 months.
Yeah, I appreciate it. It's been I think it speaks to how important the mission is, how important these industries that we're speaking to on this podcast are, and how the honeymoon of having such abundance and access to cheap energy, to infrastructure didn't fail all around us. That honeymoon phase is over.
Yeah,
and so you're seeing this in bills like the infrastructure bill. You're seeing this in literally the platform that President Biden ran off of was Build Back Better, specifically talking to people in our industries, right? It's building towards new infrastructure of the future. It's what's important for us to understand is as we transition, we have to ensure that we have it's called a just transition, and just as in like justice. The access, the thing that will kill any green initiative is people starving and freezing. When you look at what we're building and what nations and adversaries like China are building as it relates to energy and infrastructure, I mean, China in particular, 150 new nuclear sites, 50,000 more gigawatts of coal, 30,000 more gigawatts of natural gas. The U.S. kind of like opposite direction,
Mm-hmm.
less 50,000 gigawatts less of coal, um, um, 10,000 less of nuclear, a little bit more on the natural gas side. But what you're seeing is that energy prices will continue to go down, will continue to go up for the U.S. and it's already more than 2x that in Europe. And then in China, they're going down. And so if you look at and if you believe that GDP and energy are linked at the hip, there's a great McKinsey article about this. Um, it does spell some pretty concerning results in the next five years as it relates to
Mm-hmm.
who's the global economic superpower, and that puts our country and Western values at risk. And so the question that we are trying to answer through data and digitization is how can we extend the useful life of our existing infrastructure, and how do you make that infrastructure, specifically let's talk energy, how do you make it produce more?
Yeah.
And I think what's incredible is that you have all this data, like I mentioned to you before. We don't know how to use that data to optimize and make most efficient these facilities, and you don't know how to ensure that these facilities won't fail on you.
Yep.
And so you cannot have any sort of useful transition. And you've talked about this, Todd. I know you have. You can have a useful transition, a just transition, if you don't have a good bridge plan, if you don't have a way to ensure that as you are de-investing into certain areas and investing into others, that those industries that support society and our way of life, you cannot have those things fail all around you. And the largest risk to any green initiative is people starving.
Yeah.
And so it's really important to ensure that a transition to an amazing future of renewable energy, net zero, is done in a way that doesn't leave people behind.
Yeah, reliability has got to be first and foremost, because without it, the rest of it is academic, and that's not going to work. As you note, the public is incredibly intolerant of even brief outages. So longer outages are simply not on the table. So I want to drill
reading
down.
actually.
Oh, go ahead.
I was reading about. I think they're passing legislation. I think it may have already passed in Switzerland, where if you turn your thermostat up or down to the wrong numbers, you can be arrested. And it's like silly things like this that end up causing unrest and uprising, and you can't do that even in the name of ESG.
Yeah. So you kind of veered into something I wanted to ask you about as we're coming up on our time together. And so you're very invested in the technology space and you talk to other entrepreneurs. Are there other things that you see out there that are encouraging to you, or that you say there are other people like me out here who are thinking creatively about problem solving that we should kind of keep an eye on?
So I obsess about the world of making sure that we're not surprised or reactive. I'm obsessed about the world of making things most efficient.
Mm-hmm.
I think that I've seen some pretty incredible advancements on the with some of our customers at adopting and putting energy and resources into either deploying technologies like ours, or funding
Sure.
and through venture capital, funding venture capital to invest into technology that can be useful. I am encouraged by how active power, oil and gas, and other companies are on being limited partners into venture capital firms, or creating their own. One of our investors is a group called Next 47, which has $1 billion from Siemens Energy. So it's kind of like Google Ventures, but the Siemens version. I think that is probably one of the most useful ways to accelerate technology, is to specifically give funding, but then push on those VCs to look seriously at funding credible technology companies that are trying to solve these problems. I think that's in particular, spending a bunch of time in Mountain View in Silicon Valley, we were completely the wrong profile to invest in. We were robotics. We were in the oil and gas, power, manufacturing, DoD space. Like no one wants to invest in that. We were, just like solving all the wrong problems with all the wrong buzzwords, right?
Except it turns out you're solving some pretty important problems.
Yeah, so I think it's like venture capital likes safe bets, and they sometimes act like way too much like bankers than they do visionaries, and I think that's like really wrong. It's also the reason why we've chosen investors like Peter Thiel or Joe Longsdale, or we work with our investors like Founders Fund and Y Combinator, and Drive Capital with Mark Lawmay and others. These are people who like are weird, misfits, who like don't typically follow the rules of the Valley, and like that's exactly the kind of places to put your money is like people who make like pretty large bets against the path that everyone else is investing in. So I think that's I think I would. So my comments are: I know some companies that are earlier stage that are trying to solve things like measuring emissions levels at facilities, or utilizing mobile robotics or drones. I can't maybe say that I believe in the value from what I've seen yet, but I do think that I would pay attention to what investors, venture capitalists in particular, where they're investing, and like you could and tracking and having like the power and oil and gas sector pay more attention to startups. And I think one of the hardest things, Todd, is creating a partnership with a company that's been around for 100 years.
Sure.
And we've gone through that. Yeah. We've done it, and it's been like amazing to see. However, the pain that it takes to like do a partnership like that, or to get access and meetings to the right people, man, it's tough. Yeah. It's tough for people that are already building incredible tech. So we've benefited a lot through the struggle of doing it and building from the ground up. But I think this is one of the big disconnects is it's not just bad that the Valley and tech companies are so disconnected and like don't even want to invent new things in these sectors, but it's also bad for these sectors that aren't getting the benefit of the new technology. Sure. And all those amazing minds are going towards optimizing one line of code per year in Google, or we were promised a better future than 100 the technology breakthroughs of of Twitter and 140 characters. Right. Amazing. We were promised like a future of flying vehicles, and
I'm waiting for my flying car. The Jetsons were not that far away when they were originally put out.
So it's like we need to invent cool things that actually have huge value, that are solving existential threats and problems.
So let me ask you one last question, and then we'll wrap this up. As an entrepreneur that has kind of started from scratch, as you said, you bootstrapped and have kind of walked through the Valley, and now you're trending up into a very positive position, very successful position. What advice would you give the next startup that's in college, who's trying to come up with the next idea, who says, I think I can do something with this? As somebody who did exactly that, what's the advice you give them?
To protect and maintain civilization's most critical infrastructure and help give form to tomorrow is a crazy huge mission. And we need more incredible technology, both software and hardware, focused on solving the largest existential threat to our way of living. We don't think about these problems until we've spent 3 days with the power off.
Right.
And I'm not the first one to say this, but we're only a few meals away from chaos and civilization collapse. So don't let that happen. Is basically the message. And also run towards the things that people around you say are not are like the statistically the wrong thing to run towards. So you might look silly along the way. I did, and it was painful. But it's like this mentality of like, we're gonna get JFK, throwing out the gauntlet of like, we're gonna go to the moon. Right. And we did that in like 8 years. it was yeah, that's like the kind of innovation we need right now, because it might not look like it, but the world is in a very precarious place. And yeah, and I think that the impact and the potential that data and digitization can do to transform the energy infrastructure, manufacturing, and beyond, and defense as well. The impact that data digitization can have is the same kind of impact that we've seen in other industries that have adopted and figured out incredible ways to use and leverage it. And we're one way, and but this mission and what the future solutions need to be to solve these problems cannot just rest on Gecko's shoulders.
Yeah, I like your purposeful contrarian mentality. There's a reason that you sometimes go the way that's different than everybody else. So, Jake, I can't tell you how much I appreciate you taking time to visit with us. This has been a great conversation. I've learned a bunch. I've probably got more questions, but we don't have enough time. So I will leave it at that. And I will thank you very much again for your participation. You're doing your alma mater proud with the work that you're doing. So I'm glad to have the opportunity to spend some time with you.
Thanks, Todd. I really appreciate the opportunity to be on the pod.
Policy can lay a foundation for reliable, affordable, and cleaner power, but entrepreneurship and private investment, from developers of competitive power plants to technological solutions like Jake's robots, are where the rubber meets the road. We'll continue to advocate for, explore, and share stories about the many tools in place and in development to strengthen America's power system. Keep listening and learn more at epsa.org. And if you're in DC in March, come join us to hear Jake, other innovators, and energy experts at our second annual Competitive Power Summit. We'll be opening registration in the coming months. Thanks for listening to Energy Solutions. If you like this episode, please share it on social media or with your coworkers, friends, and family. You can also connect with us on Twitter at EPSA News and on LinkedIn. And subscribe, follow, leave a rating, or comment on Spotify, Pandora, Google, or wherever you listen to podcasts.
Energy Solutions is brought to you by the Electric Power Supply Association. EPSA represents America's competitive power suppliers, which bring about 150,000 megawatts of power generation resources to customers throughout the United States. Discover the power of competition at www.epsa.org.